We are live here with the awesome Dr. David Krause, um, coming at us from Colorado. So, hello everybody. This is a fantastic opportunity. I am so excited to be able to have this time with you all. Uh, David, would you mind introducing yourself so we can go ahead and get this party started?
Sure, although awesome is a hard adjective to live up to. But anyway, hi everybody, I'm Dave Krause. I am a curator of vertebrate paleontology at the Denver Museum of Nature and Science, where I've been for the last 7 years. 34 years before that, I spent as a professor of anatomy, teaching human anatomy to medical and dental students at Stony Brook University on Long Island, New York.
Awesome. That's a pretty cool history, paleontological background for 34 years.
Yep.
I bet you've
I'm an
had
old
some
man.
amazing experiences. So, yep, everybody say hello to Dr. Krause. I'm Isaac. You know me as the Vividen. I'm an undergrad student at Southern Utah University. Right now I'm studying body size variation in sauropod dinosaurs. And you probably know who I am, given that you're at the stream, but just thought I'd introduce myself again just in case we have any new viewers to the channel. So yeah, let's go ahead and get started with the meat and potatoes of our stream. Dr. Krause, how did you get started in paleontology? What drew you to such a niche field?
It's a long story, and I'll try to keep it short. I grew up on a ranch in the middle of nowhere in Alberta, Canada. Probably did not even know what the word fossil or paleontology meant. And by remote area in Canada, I'm talking about kind of Little House on the Prairie stuff. Growing up without electricity, indoor plumbing, and so on and so forth. And then one day, a grain elevator operator came out to visit my dad, and he said, "Can I take your son to go look for fossils?" And I was surprised. My dad said yes, and so I went off with this grain elevator operator for a day, and we went down into some badlands, Cretaceous badlands, and I found the cervical vertebra of a hadrosaur, and I still have that vertebra on my mantle here. And so that kind of spurred an interest in fossils, but it wasn't until I went to college, and through some connections, admittedly, I got a summer job with Dr. Richard Fox, who was interested in Cretaceous mammals. And so that was a job going into the field, and that sealed it for me because it was just a combination of being outdoors, which I love to do, and the thrill of discovery. Those two things combined told me this is what I want to do for the rest of my life.
That's pretty amazing. I have to agree with you there. The outdoors is incredible, even by itself, with all the extant fauna and everything we can learn from living organisms. But then combining it with that thrill of discovery, just like you said, the finding of something new and ancient, you can't really beat it. That's awesome.
Yep, we are humans, and we're by nature curious, and I think we're driven by that curiosity.
Exactly. What better way to satisfy that curiosity than with ancient creatures that we can't understand?
Yep, exactly right.
So you, as a paleontologist, have gained quite a reputation for yourself as an expert in Madagascar paleontology specifically. Can you tell everybody on the channel about how you got into Madagascar paleontology? Like what drew you to that environment and that particular set of fauna?
Yeah. So as an early career professor, I started a long-term project in the Crazy Mountains Basin of Montana, looking for Paleocene mammals, and we found a lot. We were doing really well. And then I had this opportunity to satisfy curiosity about Madagascar. Madagascar always fascinated me because it's got a highly unique, a highly endemic fauna and flora. And so this was in 1993, long before most of you were born. And Madagascar intrigued me because one of the burning questions in natural history was, how did that unique fauna that includes things like lemurs, how did that get there? When did it get there? And from where did it come? Nobody really knew. And it's actually in the literature in 1993 that this was the greatest unsolved mystery of natural history. So I said, what the heck? Why don't I try to get a little bit of money, a couple of friends, and we'll go to Madagascar, thinking that it would just be a one-off, that we would not be able to find anything, because the situation was that I tried to sell it as trying to find Cretaceous mammals in Madagascar, late Cretaceous mammals. And at that time, in the entire southern hemisphere, there was one locality in India that had produced just a few fragments of teeth, and one locality in Argentina that had produced some teeth and a few fragmentary jaws. That was it for the entire 35 million years of the late Cretaceous. So what were the chances that we would find late Cretaceous mammals in Madagascar? Pretty slim. And in fact, when I went to Madagascar, people actually laughed at me for thinking I would be able to do that. But as luck would have it, after 2.5 days of flying there and sleeping in airports, and then 2.5 days of driving to an area where we knew that a French soldier had found some dinosaur bones and crocodile bones in 1895. Once we got to that area, and it was late at night, we woke up in the morning and we saw some outcrop about a quarter mile away. We forgot that we were tired and hungry. We just ran over there, plopped on the ground, because, as you know, Cretaceous mammals are really small. And within 20 minutes, one of my grad students said, "Hey, Dave, I think I found a mammal." And of course, I was in disbelief. And sure enough, she had a half of a mammal molar. And I recognized it as a mammal. And we were jumping up and down, and I was screaming in French, and I don't even speak French. It was just like one of those magical moments of discovery that I referred to earlier. It was the magical moment. And as luck would have it, of course, we spent another 6 weeks there. And you can guess how many more mammal specimens we found. 0. But in the process, we found all of these exquisitely preserved bones of crocodiles and dinosaurs, and some of them were articulated. And now, 30 years later, exactly 30 years later, we have this phenomenal collection of 25,000 specimens. And to this day, there are only 13 that are mammal.
Wow, hey, at least you found some.
Yeah, and 2 of them in particular are highly significant, because they belong to a group of mammals known as Gondwanatherians, which, until we found those 2 specimens, one is a skull, a cranium, and the other is a complete and articulated skeleton. And I know this sounds like an ego trip and patting ourselves on the back, but it's all a matter of serendipity. But that skeleton is by far the most complete and best preserved skeleton of a fossil mammal from the entire Mesozoic of the southern hemisphere. And
That's
so
amazing.
yeah, it's truly an amazing thing. And both of them discovered by luck. Both of them were embedded in plaster jackets that we thought were contained something else. But that is the serendipitous nature of discovery as well.
So I'm assuming those 2 specimens that are really nice are referring to Adalatherium and Vintana.
Yes, exactly right. So Vintana is the cranium that we found, and it's absolutely bizarre. And Adalatherium is the skeleton, and Vintana means luck in the Malagasy language, and Adalatherium, combining Malagasy and Greek, means crazy beast. And the reason for choosing those kinds of names, well, based on discovery, it was luck, but crazy beast because it has so many unique characters, what we call autapomorphies, because it and Vintana and everything else in the fauna was living in isolation on Madagascar for about 20 million years, because Madagascar separated from the rest of Gondwana about 88 million years ago, and this fauna is about 66 million years old. And so really the bottom line, and it's characteristic of everything that we find. I often joke about the fact that I can summarize 30 years of research in one sentence, and that one sentence is, that if you live alone in isolation for millions of years on an island, you get weird. And everything we find is incredibly weird in one way, shape, or another.
Yeah, I think that's so cool, especially with the recent, like season 2 of Prehistoric Planet, highlighting a lot of those very same animals that your team got to discover and showing just how bizarre they were compared to their mainland counterparts or their extant counterparts. Let's go through some of those animals that you've discovered and talk about each one, why they're unique, what makes them special as an organism, and what makes them special to you. So I guess to start off with Vintena and Adulatherium, is there anything specific that you haven't already mentioned that you'd want to kind of highlight? If you could distill what's amazing about those particular animals into a few minutes, what would you say?
Yeah, so a picture tells 1,000 words, and if you saw images of these animals, you would see that, well, at least with regards to Vintena, that it is totally bizarre. And one of the most bizarre things is that it has these massive jugal flanges, flanges coming off the zygomatic arch of your face, but they come down and they're for attachment of jaw closing muscles. That makes it look really, really weird. It's got the largest olfactory bulbs of any known extant or extinct. And Adulatherium has weird things like more thoracic and lumbar vertebrae than any other known mammal. It's got this weird vacuity in the middle of its nasals. And there's no counterpart in modern mammals, so we have no idea. I mean, you can throw any wild speculation out there, and you might be right. But Vintena alone, well, each of them have just this whole range of unique characteristics that makes them bizarre. And maybe the most unique is because there's this common conception of Mesozoic mammals as being shrew and mouse-sized and running around between the toes of dinosaurs. And both Vintena and Adulatherium are massively big compared to shrews and mice. They're obviously not the size of cows or anything like that, but Vintena was probably about 8 kilograms in size, which makes it the second largest mammal from the entire Mesozoic of anywhere in the world. Wow. And Adulatherium was probably about 2.5 to 3 kilograms in size. So, a small badger size.
Well, that's pretty amazing. I didn't realize that they were so big.
Yeah, they got big. And the largest known Mesozoic mammals were Penomamus, which is from the early Cretaceous of China. And that's roughly fox-sized.
It's pretty amazing. The idea that there were mammals that were successful and like the size of a large house cat even running around the Mesozoic is pretty amazing.
Yeah. No, that's a good observation. That's it is not how we normally think of Mesozoic mammals, but on Madagascar they were seemingly quite big.
Interesting. Why do you think on Madagascar specifically the mammals were able to maintain a body size that was so much bigger than the rest of the Mesozoic land?
It's a good question, and I don't have a good answer because you pretty much have to be there during that time. But there is a lot of hypotheses out there about what happens on islands, and sometimes it's called insular gigantism or insular dwarfism. And in the case of these mammals, that could explain that in the context of a unique environment relative to the mainland, that there were just these niches available where the mammals could grow quite large, evolve quite large.
That does make a lot of sense, and there's plenty of examples of that in the fossil record.
Yeah,
I think
exactly.
Dwarfism could be an explanation for why the theropods on Madagascar, for example, Majungasaurus, weren't quite as large as the larger theropods in other land masses.
Yeah, it could well be. The problem is we only have that data point, and we don't have. Well, we might actually, but we don't have any knowledge of how that lineage started out when Madagascar became isolated. What you would love to have, of course, is a pretty complete fossil record, and whatever was on that lineage to confirm an hypothesis of insular dwarfism. You would love to have a Majungasaurus ancestor on Madagascar that was isolated, that was much bigger than Majungasaurus is today. But we don't have that, and it could actually be the opposite. In other words, the ancestor of Majungasaurus might have been really, really small. We just don't know. We've got that one data point.
It's true. And it's especially hard to tell with the Beelosaurids in particular because they tend towards the smaller body size range for large to medium theropods.
Yes.
So it may have been that size anyway. Most of Beelosaurids kind of were in that range.
Yeah. Yeah, that's a good observation.
It's awesome. Oh, it looks like Majungasaurus is actually the next taxon on our list. Tell us about Majungasaurus without repeating what we already discussed, I suppose. What are your favorite things about the animal? What makes it unique and fascinating to you?
Well, one of the things is its history. So the French were in this same area, and I could give a long explanation of why the French or the Italians or the Japanese, who were in exactly the same area that we worked, didn't find much. Actually, I'll sidetrack and explain that anyway, which is that they were looking and collecting things off the surface, and the climate in Madagascar is incredibly harsh, and the sandstone is quite soft, and so anything that erodes out gets pounded to smithereens. And what they didn't do, and we did, I know this sounds like an ego trip as well, but what we did was we found concentrations of bone and then started excavating and going into quarries, and only 2 inches below the surface were these beautifully preserved and sometimes articulated specimens. So anyway, one of the bones that the French had collected, I think in the 70s, was described in 1979 by Hans-Dieter Seuss and Philippe Taquet as a pachycephalosaurid. And that was because it was a frontal, and the frontal was very, very thickened. And if you know what Majungasaurus looks like, it has this funny frontal horn. Well, that's what it was. And so they saw it as being incredibly thick. And logically, at that time in 1979, said that, oh, there must be a pachycephalosaurid on Madagascar, and they named it Majungatholus. And then, of course, we had the good fortune of, in 1996, discovering a complete skull, and found out that dome was actually sitting on the top of a theropod skull on a belosaurid, as you said. And so that allowed us to, change that taxonomic assignment from Pachycephalosauridae to Belosauridae. Quite a switch.
That's really cool. Why do you think morphologically that was selected for in a theropod of all things?
Yeah, don't know. My best guess, and I think anybody's best guess, is that it somehow may have to do with sexual selection, that just having this funny bump on the top of your head makes you look sexy. But I don't really know if that's the case. Mm-hmm. And the other peculiar thing about Majungasaurus is that perhaps the most, again, I'm not a theropod expert, I'm a mammal guy, but the thing that still strikes me as odd, and I actually had a grad student try to investigate this, is the peculiar pectoral girdle and the forelimb. It's got this massive scapulocoracoid. It's really, really big, but it's got these tiny little limbs, and like they're diminutive, like in a T-Rex, except that unlike in T-Rex, there aren't even claws on the ends of the digits. They're just these tiny little nubbins on the ends of the digits. So that strikes me as a pretty odd thing as well. And the other thing that's odd about it is that the frontal it's kind of like a Roman nose, what's referred to as a Roman nose, a big procumbent nose on the theropod, and it's got this really roughened architecture on it. but it's also hollow inside. And those are probably some of the strangest features about it.
That that is really strange. I,
Yeah.
Abelosaurids in general are just a really interesting group. I know there's kind of a bit of a paleo meme around the community to refer to them as like speed sausages or demon sausages, or they're just long and skinny like dachshunds, but gigantic carnivores.
Yeah, and some of the perception of Majungasaurus being long and skinny is that the earliest reconstructions that we had of that were based on kind of piecing together associated elements, and as it turns out, now we have articulated postcranial skeletons, and really quite exquisite ones that are still not fully published, but they're articulated, and it shows that we probably got the limbs, the hind limbs, a little bit too short.
Really?
Yeah, so it's probably a little taller and less drawn out, therefore, than originally reconstructed.
Wow, that's really cool.
Yeah.
Yeah, thanks for sharing that little secret tidbit about Majungasaurus. That's awesome.
Yeah, stay tuned.
We know we have a lot of literature about that particular animal to look forward to now.
Yeah, yeah, and Mashikasaurus is our other abelosauroid, and Noasaurid, and so we could actually speculate too about why it's so small. But to use your argument, Noasaurids in general are relatively small, but Mashikasaurus is probably the most peculiar feature is those teeth, the anterior teeth that point straight forward. And there's all kinds of speculation. It's been reconstructed as a piscivore, a fish eater, because of those long teeth that they might have been used for stabbing. But again, that's kind of that it is speculative, so we don't really know. And a story that you and your viewers may not know is that so we've often, everything we find in Madagascar has been new to science, and so we get the joy of naming those animals, and oftentimes we try to incorporate a Madagascar-based word into it. So Mashikasaurus is basically, Mashika means vicious and saurus means lizard, so vicious lizard, but we ended up naming it Knopfleri. And do you know the story behind that?
I was actually just about to ask you if it was true, if it was like an urban legend that it was named after Mark Knopfler.
Yeah, it is, and so I take some credit for that actually, because you know, when you're out in quarries like we are, you're sitting in the hot sun digging away for days and maybe hours and not finding very much. And my grad students would oftentimes say, you know, can we play some music? And of course I'd say yes, because I, you know, like all kinds of music. But every once in a while we got to play my music, and I happened to like this old time rocker, singer, songwriter, guitarist by the name of Mark Knopfler. And so it just seemed, don't even know that I could document this, but it just seemed that every time we played my music, we'd find bones of Mashikasaurus. And so we decided that we would name it after Mark Knopfler for that reason. And Mark Knopfler, FYI, is roughly the same age as I am. So he's up there, but I really like him. I think he's very, very talented. But there were two benefits of doing that. This is when I was still teaching at Stony Brook University, and we knew that he was coming to New York to give a concert. And so somehow or another, we connected with his agent, and we got 7 free tickets to a concert because we named this dinosaur after him. And the other benefit was that there's now a replica of the skeleton of Mashikasaurus in some rock and roll museum in Scandinavia.
That is awesome. I did not know that.
Yeah. So there's more urban legends.
That's so cool. This is really just a spectacular experience for me in particular, because I remember reading that story in dinosaur books when I was like 5 or 6 years old and thinking, wow, paleontologists, they get to choose the names? That's so cool. It just blew my little kid mind. And so getting to actually hear that story from your own mouth and your own words is just really awesome. Like, bucket list item checked off for me.
Yeah, well, sometimes we're just pretty boring and conservative about names that we choose, but that one and another one that we'll be talking about actually next, I see it on the list, is Beelzebufo. So Beelzebufo is arguably one of the heaviest frogs that ever lived, and it's closely related to, or we think it's closely related to, frogs that live in South America today. And pardon my language, but they're badass. They are really, really tough frogs. They're vicious predators. They're sit and wait ambush predators, and basically they take their butts, they squiggle down into leaves or sand and just wait for something to come by. And so Beelzebufo, this frog, this hyloid frog, has been painted. It's actually an image in a National Geographic magazine as taking down a hatchling Majungasaurus. And I love that concept of frogs eating dinosaurs. And I think in the what was a Prehistoric Planet footage, they just did a really scary image of it leaping out of water and coming at something. But anyway, it's Beelzebufo is really, really strange because of its big size, but also because it's armored. Frogs don't normally have armor, but this thing had armor going onto its back. It may have had armor extending even further than that, and so the species name is called Ampinga, and that means armored. But the Beelzebufo part of it comes from the fact that when we first started finding individual elements of this, we knew that it was frog and we knew that it was big. And so we would just amongst ourselves, we would refer to it as the frog from hell because it was so big. And then we decided to kind of incorporate that into the name, and Bufo means toad and Beelzebub means the devil. And so that's how we came up with the name Beelzebufo.
That's awesome. I love Beelzebufo. I think it's hilarious and terrifying at the same time, which is a wonderful combination for a prehistoric animal.
Yeah.
Funny story. My friends and I actually ran a Dungeons and Dragons campaign about a year ago, where a group of Beelzebufo was the main villain of the campaign because they were so powerful and scary. But yeah, I just think it's so cool that there was a frog that was big enough and predatorily adapted enough to take on small dinosaurs. Like, that thing could probably swallow a cat. That's so cool.
Well, it could potentially have done that because these ceratophrine frogs that live in South America today, that we think are related to Beelzebufo, but are only about 4 inches long. There's a story, it's published in Nature, just a note in Nature, in the journal Nature, of a herpetologist in the American Museum of Natural History. He was sent some frogs and other reptiles from South America, and he didn't have enough aquaria to put things together, so he resorted to putting an 11-inch alligator, so a small alligator, in with this 4-inch ceratophrine frog. They're called Pac-Man frogs because they're all mouth and stomach. And anyway, he came back the next morning and only the frog was in the aquarium. And so he looked all over the place for the alligator and couldn't find it, and then came to the conclusion that the frog had eaten it. So he actually x-rayed the frog. And yes, inside this 4-inch frog was an 11-inch alligator. Of course, most of that is tail, but still quite a feat and representative of how vicious they can be. So scale that up to Beelzebufo, and you've got a pretty vicious animal.
That's insane. I didn't think that they could take on. I mean, I knew Pac-Man frogs were voracious little critters, but taking on something that big, that's amazing.
Yeah, it must have been hungry.
It must have been really hungry. Pac-Man frog is a good name.
Yep, exactly.
That's awesome. Thanks for that insight on Beelzebufo. Speaking of animals that tend to flip the ecological role a little bit, let's look at Simosuchus.
Yeah. So I don't know what the correct pronunciation is. We usually say Simosuchus. It could be Simosuchus. I don't know. and don't much
I
care.
didn't name it.
But it's an odd animal. I've got a sculpture of it, and when I do behind the scenes tours at the museum, I pull it out and I ask the kids, what is this? Is this a dinosaur? Is it a lizard or a crocodile? And I get almost equal answers. So for the viewers who don't know, it is a crocodiliform. It's a Neosuchian crocodiliform, and it was probably the size of a large beagle or something like that. And most good card-carrying crocodiliforms have got a long, slender snout and conical teeth for catching prey. Simosuchus does not. It's got a pug-nosed face, and it's got leaf-shaped teeth instead of conical teeth. And so and these leaf-shaped teeth are almost identical in shape to those of green iguanas. So we, of course, made that analogy and that speculation to say that actually Simosuchus was a vegetarian crocodile. It was an herbivore, and that's pretty odd to begin with. So not only does it have leaf-shaped teeth and a pug-nosed face, it's heavily armored. And so instead of just osteoderms, these skin bones going through the body, it's covered down both limbs. It looks like a little tank, and it's even got bony palpebrals, in other words, bone inside of the eyelids, so that you can just imagine these eyelids clunking shut when it closes its eyes. So it's a very odd animal, and again, kind of representative of the weirdness that can happen when you evolve in isolation.
That's amazing. I remember when I was showing my wife Prehistoric Planet season 2, the Madagascar episode, and as soon as Simosuchus came onto the screen, she nudged me with her elbow and said, "Can we get one?"
Well, I often joke too that I would love to have one and take it out for a walk, put it on a leash and take it out for a walk.
Out of all of the strange prehistoric fauna that Madagascar has produced, that might be my pick for a pet. It's the perfect size, little small dog size, but it's probably a little less yappy.
Yeah.
One man just going to make the Chihuahua noises. Plus, it's so adorable, and it can protect itself. It's the perfect combo.
Yeah, I happen to agree with you, but I'm pretty biased.
It's hard not to be when it's a little adorable pug crocodile.
Yeah.
That's amazing. Okay, it looks like the next item on our agenda, and the last one before we head to the question and answer section. So everybody in the chat, go ahead and prep your questions now, and we'll get to them one at a time. Let's talk about science with a social conscience. What is that initiative that you've been working with, and can you tell us about kind of what it means to you?
Yeah, well, it means a lot to me, and I could probably talk for several hours about it. I'll try to keep it short. Which is, there's a lot of attention being paid in the recent literature, the very recent literature, to colonialism and paleontology and about neocolonialism, and I think that's appropriate. And I think colonialism, whether neo or not, is bad, and there should be a lot of corrective things done in regards to that. And I'm not saying that we are the example to look to, but I'd like to think that even though we've made mistakes, even though we know that there's much more we can do, that I'd like to think that we've done some things right. And so a lot of the neocolonialism refers to parachute science. In other words, scientists from countries that are relatively well off going to countries that are not well off, and not engaging with local paleontologists in this case, or interacting with the local communities. And in other words, they just parachute in and get their stuff and parachute out. That's the comparison. And so we've worked in this, one of the field areas, we worked in the same field area for about 30 years, but very soon after getting there, we were struck by the poverty. Madagascar is the third poorest country in the world. The median annual income is $398 annual. It's heartbreaking because that there's a disparity in wealth, but the vast majority of people are incredibly poor. And we saw that, and so it came about that in the first year, in the first few days, we recognized that there were kids following us all over the place. You know, we'd be walking 10 miles, there'd be kids following us. They were intrigued by us. We looked differently than they do. We had things that they had never seen before, like pens and paper, and then later we had cameras, and then we had laptop computers, and even later we had GPS, handheld GPS units, and they'd never seen anything like this. And so we ended up asking the logical question is, you know, why are you following us around? It's a Monday, it's a Wednesday, it's a Thursday. Why aren't you in school? And the answer, of course, was there was no school. And then we learned that nobody in the village, nobody, adults or children, could read or write. And I held a meeting with the village elders, the village chief, and said to them quite honestly that you've been very kind to us. You've welcomed us into your community. You've showed us where you think some dinosaur bones are. You even helped us carry out some plaster jackets. What can we do to help? And I didn't really know what to expect, but the answer I got was, we would like for our children to get an education, because they knew that that was their way out of poverty. And so, you know, my next question, you know, I'm just a paleontologist. I wasn't really expecting that, but the next logical answer or question was, you know, well, how much would that cost? And they said, well, you can hire a teacher for $500 a year. And so I went back to camp, and we pooled some money, and we started a school. And the first school started out as a class with one teacher underneath a mango tree with a blackboard nailed to the tree. And one thing led to another, and I went back to Stony Brook, and I established a not-for-profit organization called the Madagascar Ankisi Fund. Ankisi means children in the Malagasy language, and so it's focused on helping with education and healthcare. And the healthcare part of it comes in that you know, we'd be there for 6 weeks, and in my case, at least, separated from my own very young children. And so we got to know those children really well, and they were just wonderful, adorable children. They'd crawl all over us like children do, and we have things that they had never seen before but really desired, like a soccer ball, and we'd give them extra food in camp and so on and so forth. But so the bottom line is we get to know them really well, and we come back the next year, and some of them were not there because they died of easily treatable diseases like respiratory infections, diarrheal disease, and malaria is a big killer. So the Madagascar Ankisi Fund is dedicated to helping with education and healthcare, and over time we've built 6 schools. 5 of them are primary, 1 of them is secondary. Some kids have excelled in those schools, and we've supported them to go on to high school and even into university. So now, in a village where nobody could read and write in 1993, there are kids that have a university education. And some of them want to come back into their original communities and help out. And so we support them. And right now we're supporting a woman who's a midwife and a paramedic. We're supporting a young man to build a fish farm to get much needed protein. And we're supporting another young man who, with his business degree, has started a women's permaculture association. So now we have a whole bunch of women who are growing crops that weren't grown before. So that's one aspect of it. And with regards to colleagues, we've tried to build up paleontological infrastructure in Madagascar, and so we work primarily with the largest university in Madagascar. It's the University of Antananarivo, and we've tried to provide them with graduate students with training. We bring them here for training in everything from research to collections management to fossil preparation. We have built a collections facility there, and I got that the funds to do that from Stony Brook University. And then when I moved here, we had some extra specimen cabinets, and we sent those to Madagascar. So now there's a reasonably good collections facility in Madagascar. So we're trying to do those sorts of things. And we're also trying to educate the Malagasy public about their very rich natural heritage. And so we do that in so many different ways, like public lectures and talking to the media and putting up informational signs on the major road in our field area, a number of different things. So the neocolonialism label is hard to avoid, especially since I am an older white male. And that's just, that's who I am. I can't do anything about that. But I'm going from a developed country into a developing country. But as I said before we went onto the air, even if I can't avoid that label, I'd like to be the most caring and responsible and supportive neocolonialist I can be.
Yeah, exactly. I think you're completely right that if we're in a position where we can, we have the opportunity to choose between being a parachute scientist or an infrastructure building scientist, someone who can either take and just leave with, kind of letting the people do their own thing, or somebody who chooses to use their privilege and their ability to help the people that you work with build up their own infrastructure and society more, helping them help themselves. That's a really fantastic initiative that you're doing. That's really important.
Yeah, and I don't want to make it sound like we're the only ones in the world that do that. There are many other examples of people trying to give back to the developing countries in which they work. It's just that mostly in the news and even in the scientific literature, you hear about neocolonialism in paleontology, and some of those are country specific, like Brazil and Mexico and Myanmar, and so on and so forth. But I'd like to think that it's not all negative.
Yeah, that's definitely an important consideration to have in any scientific field, and especially paleontology.
Yeah, exactly.
Okay, awesome. Well, that concludes the first section of our live stream, and we're going to go ahead and move on to the question and answer section. We have a few built up in the queue, so we're going to go ahead and go through one at a time. We're planning on ending at about 5:30 Mountain Daylight Time, so we've got a little under 20 minutes for these questions. So let's go ahead and get started. Looks like Don Fairfield. I never heard about armor for them. I presume you're referring to Beelzebufo osteoderms, a shell. Can you talk a little bit more about what that armor structure looked like for Beelzebufo?
Yeah, so Beelzebufo, and I referred to that, I think. If I didn't, I should have, with regards to Simosuchus. So any crocodiliform that lives today, an alligator or a crocodile, actually have bones within their skin, and those are referred to as osteoderms. So they're in between the epidermis and the dermis. And so it's just that they've not been identified, to my knowledge, in the postcranial skeleton of any frog. So that makes Beelzebufo unique. And with regards to Simosuchus, they extend down onto the legs farther than they do on most crocodiles, and they're thick. And so, it looks like some kind of war machine, this little armored tank, Simosuchus does. And the other interesting aspect of it is that we find very large plate-like osteoderms, and they almost undoubtedly are assignable to titanosaurid sauropods. And sauropods, especially saltasaurians from South America, have been identified as having osteoderms. And the problem is for us is that we don't know where they are on the skeleton. And we've actually got one massive one that, if you didn't know any better, you'd think was a tail club, like on an ankylosaur. But most of them are not like that. But the bottom line is, and I don't know if you can see my fingers here, but some of them are about 4 or 5 inches thick. And so just think of what that means. I mean, those are skin bones. Those are bones within the skin between the dermis and the epidermis, just this thick armor-like protective bone within it. But kind of gives you a new perspective on skin in having such thick skin.
That's amazing. I didn't know there were titanosaurs there. That's the first I've heard of it. That's incredible.
Yeah, so there are two actually. One is called Rapetusaurus, and it's arguably, again, this might reflect a little bias, but it's arguably the most complete and best preserved titanosaurid from anywhere. But it's not. If you look at any phylogenetic tree, over time, it bounces around all over the place. And for a while, it was aligned with Nemectosaurus from Mongolia, but Nemectosaurus didn't, at least in the past. I'm probably not up on the literature. Didn't have a skull, and so you couldn't make the comparison with the skull. But since then, in speaking to some titanosaurid experts, Rapetusaurus continues to bounce around on the tree. And that again might reflect the fact that it, like everything else, is weird. And so it's kind of hard to peg into any standard titanosaurid phylogeny.
That's awesome. Okay, next question, also from Don, talking about Simosuchus this time. What small predator could have made pug croc armor viable? It couldn't be effective versus larger predators, right?
Yeah, I would think so. And if I understand the question, there were late Cretaceous of Madagascar was a vicious place. It was. I mean, true, we didn't have any large theropods like T. Rex, but we did have Majungasaurus, and that could, I would think, easily have dined on a Simosuchus, for instance. But in addition to that, and what's really kind of interesting from a ecomorphological point of view and dividing up niches is the fact that we've got 6 crocodiliforms. Simosuchus is only one of them, and it's the second smallest. The smallest is Araripasuchus, but there are 2 that are kind of medium-sized, and then there's 2 monsters, Majungasuchus, not Majungasaurus, but Majungasuchus, and Miodonasuchus. Those were large crocodiles, and I think that they too would have relished a meal of Simosuchus.
Awesome. There's a niche for everything.
Yeah, exactly.
Okay, from Nasty Allosaurus, is it possible that the lungs or stamina of the predators were more developed than other theropods because of the heat in Madagascar?
Wow. That's a question for my colleague Pat O'Connor, because he has actually worked on pneumaticity in the bones of Majungasaurus in particular, and he did that for his PhD dissertation back in the late 90s, maybe early 2000s. And so he did a lot of work comparing to birds and really laid out completely the whole development of the air sac system within the vertebrae, into the limbs, into the ribs. And so, yes, Majungasaurus had a very elaborate pneumatic system, including its lungs. Of course, we don't have the lungs to look at, but it's an interesting observation, interesting thing to think about, whether it was greater than in other theropods. And to do that, and I don't think this study has been done, the only way you could probably really get at it is by the things that are preserved, which are these pneumatic foramina within vertebrae and ribs and limbs, and see how that scales relative to other theropods. So I don't think that study has been done yet. So that's why I can't fully answer your question. But I can also add anecdotally that we have the paleo environment pretty well pegged. We don't have yet a measure of paleo temperature, but we've got an estimate of rainfall. And we've also got enough information from the paleosols, the fossil soils there, to know that it was a very, very hot and dry environment for much of the year. And then there were, these heavy rains, and they caused these debris flows. And debris flows are essentially flash floods with a lot of sediment in them. So they're basically kind of milkshake consistency. And so, and I'll go on a little tangent here, but I'm doing it because I think it's interesting. When you think about paleo environment and how we find bones, we can walk out there and it's the richest, it's the most, even though it's not all that well exposed, it's the most fossiliferous area I've ever worked in. And I've been doing field work for 50 years. And you can't walk anywhere without bones being underfoot. And so there's part about the modern climate that I referred to, but the paleo climate is instructive, I think, when you think about the scenario of, say, 9 or 10 months of hot, dry weather, just beastly hot, and then 2 or so months of heavy rains and debris flows and everything else. So imagine something dying on a floodplain after the rainy season. It's going to sit out there for 8 or 9 months, 10 months maybe, of just getting scavenged by scavengers, eaten up by beetles, bleached by the sun, and the bone is going to just be not very good. It'll be broken apart, it'll be weathered and everything else. And we see a lot of that. And so the closer you get to the rainy season, though, the better chance you have of something still being reasonably well preserved, even if maybe associated. And then even closer to the rainy season, something that might even still be articulated. And then just before the debris flow, you might have animals that get caught in the debris flow still living. So the point being that is the closer you get to the debris flow, or maybe in the debris flow, is the best chance for getting these complete and exquisitely preserved skeletons, because as we all know as paleontologists, the best way to get good preservation is to get buried rapidly and excluded from the elements. And so we think that the reason why we get these really wonderfully well preserved and complete skeletons and skulls is because they were either pretty close to the time of the debris flows or actually buried alive in the debris flows.
That's really cool.
Yeah, I think it's a neat story. And so the other aspect of that is that in some areas we get very rich concentrations of bone, and oftentimes they're just above a heavy layer of sediment that we think was probably an algal mat. And so the scenario there is that, during these hot, dry times, there are these, there's less and less water. And so there's these ephemeral ponds, animals coming there and dying there. And that's why we get these rich concentrations sitting on top of these algal mats.
That's awesome. A question from Tarbtano, if there's time. There is, fortunately. What sort of pterosaur fossils does Madagascar have? And has a professor ever done work on Cenozoic fossils like subfossil giant lemurs?
Yeah, so pterosaurs, the answer is no, that we don't have any, except for in another basin, one of my former grad students discovered a distal part of an ulna, and that remains undescribed. So stay tuned on that. I have no idea what it is. Have I ever done work on Cenozoic fossils like subfossil giant lemurs? No. But as the questioner clearly knows, there were some lemurs there that were in fact giant. They were the size of gorillas, or something called archaeolemur that was the size of a gorilla. And there's also these giant elephant birds, and elephant birds were the largest birds that ever lived. And the name escapes me. It starts with a V. But anyway, it was relatively recently discovered, and I think humeri were discovered and some other limb bone elements, and they scaled those, and that particular man, the name was very Varumbe, I think, Varumbe, which is a Malagasy word. Anyway, that scales up to be a bird of 1,600 pounds. That's like a bull.
That is hefty. Wow.
Yeah, yeah. Imagine that drumstick on Thanksgiving.
Yeah, you could feed an army with that. From Tyrannorex, it seems Beelzebufo has specimens that were able to make more room to grow. Assuming more growth, how do you presume it stacks up with that enormous calyptocephalid from the Eocene?
Yeah, good question. And I can't, again, here's where I plead being a mammal expert, not a frog expert. But it was up there. There's a lot of speculation about how big Beelzebufo was. In our original paper in 2008, we had an estimate that was probably just a little bit too big. And so with more fossils in 2014, we scaled that back. And the questioner may know that there was a study done on the bite force of Beelzebufo, and I should have mentioned that earlier. And it scales up to have a bite source equivalent to that of large mammalian carnivores like wolves.
That is so cool.
It was vicious, but exactly how it stacks up against the calyptocephalid, I'm sorry, I can't comment.
That's fair. From Cassave, if you got to be a scientific consultant for a paleodoc on the fauna of Cretaceous Madagascar, what would you like to see in that documentary?
In a documentary, I have to say that
as the consultant, what would you pick?
So I don't know that it would be any different than Prehistoric Planet and the 6 or so animals that you targeted, Isaac. I think those are some of the most fascinating that we have. And we also have the largest snake known from the Cretaceous of anywhere in the world. It was about 7 meters, maybe even 8 meters long, Matsoia madagascariensis. So it's interesting that you asked that question, because we kind of ask those questions too. In some ways, the scientist in me says I don't care, but as a human being, I do care. And one of the reasons I care is that I'm always looking to raise funds for the Madagascar Ankisi Fund. And I know that you had Brian Curtis on this live streaming event a few weeks ago, and he, for instance, is helping us out by marketing casts of some of the animals that we have, and so some of the royalties from that are going towards the Madagascar Ankisi Fund. Ankisi, by the way, is spelled Ankizy. You would think it wasn't an I, but it is an I. And so, it's mainly for that reason, I'll be honest with you, mainly for that reason that I love to see our animals get out into the public view, is so that we can find some way to turn that into helping Madagascar paleontology in general and helping the kids in our field areas.
That's amazing. Okay, we've got time for a couple other questions. From Luca Ricci, how valid is the existence of the speculated 8th continent of Lemuria in relation to the paleontological record?
Wow, these are some great questions. You've got some great people that are asking very fine-tuned questions. So yeah, the lost continent of Lemuria. This comes up a lot, actually. Well, no, I wouldn't say it comes up a lot, but it's important in the sense of trying to figure out the biogeographic history of Madagascar. And so if there were these land masses that we don't really know and that were emergent during, say, the Cretaceous, then you have ways of getting animals from Madagascar to other places, or from other places to Madagascar. And so, that would therefore question whether or not Madagascar really was isolated, and this whole scenario of evolving in isolation. So Lemuria is one example. There's another example of the Kerguelen Plateau, which still is emergent today, but it's a pretty small spot of land. And there was a lot of speculation, and I was involved in that speculation, and I now know it's not I now know it's not true, which is that the Kerguelen Plateau served as a land bridge between the Antarctica and the combined continent of Madagascar and the Indian subcontinent, which we've referred to as Indo-Madagascar. And so that I don't have time to get into it in detail, but that came about because we saw similarities between the animals that we found and those in South America in particular. And so there was a potential for a route from South America into Antarctica through the Kerguelen Plateau up into Indo-Madagascar. But now we know, because I engaged a geophysicist or someone with more geophysical training than I do, to look at that in some detail, and proves that the Kerguelen Plateau was not emergent to the extent that it could serve as a land bridge to Indo-Madagascar during the Cretaceous. And then another one is the Davy Ridge in between Madagascar and the east coast of Africa. Is that a means for which lemurs and tenrecs and all kinds of other ancestors of the modern fauna in Madagascar could have gotten to Madagascar? And so the geophysical evidence for that is pretty slim as well. But these are really important things to look at, and these are hypotheses that are out there, and the best way to test them is to work with geologists and geophysicists in particular.
Exactly. Every science is secretly interdisciplinary.
Yeah, exactly.
Okay, I think we've got time for 3 more really quick questions. Let's go with this one first. Thoughts on prehistoric planet sequences, such as the Majungasaurus children getting hunted by Beelzebufo, Matsuya attacking the Majungasaurus, and the Beelzebufo's journey?
I'm embarrassed to say that I didn't subscribe to Prehistoric Planet. I've only seen snippets of it, and I just finished. I was whining to Isaac earlier that I finished this administrative post as an interim director of Earth and Space Sciences here at the Denver Museum of Nature and Science. And maybe now that I'm done with that, I'll have a little more time to look at Prehistoric Planet. I've just seen a few little snippets of it, and the one that it was sent to me by a colleague on Adalatherium, which you don't list in your question. I thought Adalatherium was depicted in a truly logical way, and I thought it was really, really cool. I thought that I saw the clip of Beelzebufo leaping out of the water, and I think they kind of overdid the size of Beelzebufo, but I can't blame them for that either. It did make it look to be a very terrifying animal, and I've given you examples of why that might have been the case in terms of bite force and then comparisons to the Pac-Man frogs.
Awesome. Okay, second to last question from Rhedosaurus. Considering how a Turriosaur has been found, what are the chances of an Allosaur or Carcharodontosaur being found in Madagascar as well?
Yeah, possibly. What we're getting, this would normally be a very long answer, but what we're getting, the signal that we're getting from the phylogenetic analyses that we have, whether it's frogs or whether it's belissaurids or noasaurids or crocodiliforms or mammals, is that we have very, very extensive ghost lineages. So in other words, very long periods of time. So the phylogeny of each of these animals that we find has to be traced back to a very, very early time, probably close to the early and late Cretaceous boundary, or even into the early Cretaceous. And so and we get that independently. And so I think it's a valid pattern, and that would suggest that we don't necessarily expect to find something that's closely related to things in South America, or certainly North America, or even Antarctica. You would expect, based on the sequence of fragmentation of Gondwana, the southern supercontinent, that the closest relationship should be to those animals that lived in on the Indian subcontinent at roughly the same time, because that was the last landmass closely connected to Madagascar. And we actually do see that to some extent. And we see that in a particular one form of snake, some turtles that we have, and even within abelisaurids. And so I think it's maybe Rajasaurus that is oftentimes depicted as a close relative of Majungasaurus. That's a little more iffy, but the snakes and the turtles in particular seem to show closer relationship to snakes and turtles that lived on the Indian subcontinent.
Interesting. And then last question from Heatwave Edits. I have a question. What would happen if Carnotaurus was on Madagascar instead of Majungasaurus?
Well, Carnotaurus, as you know, is bigger and probably badder than Majungasaurus, so it would probably had a good time on Madagascar.
Probably would have. Be a Bilosaurid party all
Yeah.
over the place. Okay, awesome. Well, thank you so much for joining the stream, everybody who came. Thank you so much for being on the channel. Dr. Krause, this has really been a like I said, a bucket list item for me, getting to meet someone who's worked with some of my favorite animals and been part of their stories.
Well, it's totally been my pleasure. I really appreciate the interest.
Awesome. Thank you again, everybody, and we'll see you next time.